All right, let's check out another example in section 8.1. Kind of a wordy problem, but it'll make sense. So the specific absorption rate for a cell phone measures the amount of radio frequency, so the energy absorbed by the user's body when using the mobile device. Every cell phone emits RF radio frequency. Different phone models have different specific absorption rates measures. To get certification, we need to have an SAR lower than 1.6 watts per kilogram. Next slide shows the table with the highest SAR levels for phones. We want to have like 98% confidence interval for the true population or the average of the specific absorption rates for cell phones. So we're going to take a group of phones and find the 98% confidence interval for where the average will be. And for this, we're going to assume the population standard deviation is 0.337. And here is our data set. So we have all of our different phones and the SAR values. So the Motorola V195S has the highest. Some other Motorola's look like they have about the lowest. But that's kind of beside the point. So there's our data set. We could use this population to find the average, and we could use this to find the standard deviation. They're going to give us those numbers for us. To calculate that, we could put these numbers into Google Sheets and go to equals average and then equals standard deviation and find out what those are. So we're looking for the 98% confidence interval. So I take that into my inverse normal distribution calculator, and I put in an area of 0.98, a mean of 0, standard deviation of 1. And it's going to tell us, remember, I can't put in our mean and standard deviation because we don't know those values quite yet. And well, we know the mean. We don't know the sample standard deviation quite yet. And so we're going to look between these numbers here. So this is going to tell us from the average, we're going to go 2.326 sample standard deviations to the left, and we'll go 2.326 standard deviations to the right, and 98% of the averages from our samples will land in that region. All right, so to do this, we're going to calculate these values. So we found that z-score, 2.326. So that's going to be our z-score here, 2.326. Next, we put in the standard deviation, 0.337, they give that to us, divided by the square root of the sample size. Our sample size was 30. And calculating that, we get 0.1431. That's our EBM. Then we take that and we just add that and subtract it to the average. The average for this, if you go into this data and calculate the average, you get 1.024. So we take 1.024, we subtract the EBM, we add the EBM, and we get our range of values. So 98% of the averages, when we grab a sample, will land between 0.88 and 1.167. So we have a 98% confidence that the true SAR mean for the population of cell phones in the US is somewhere between 0.88 and 1.167. And we wanted everything to be below 1.6, right? So we have a very large confidence that the SAR levels are definitely within safe zones or safe region. And there's how you can type it into the graphing calculator if you want to do that. All right. And there we go. That's it. Thank you.